Okay, Java SE6 top 10 features. Yeah, by the way, I got one comment on my Twitter. Are you talking about Java SE7 or are you talking about Java SE6? And that's actually a fair question because Java SE6 has been around for several years. So this is kind of old. So that's actually a fair question. So I responded that this is one of the topics we cover in this course. And of course, we are going to spend quite a bit of time on Java SE7 in this course at the end. So these are top 10 features of Java SE6: scripting, web services, database enhancement, desktop APIs, monitoring and management, compile access, and things like that. So let's move on to each of these features in detail. First, scripting support has been added to Java SE6. So why we need scripting support in Java? Isn't Java enough for writing any kind of application? The answer is not really. I mean, a lot of dynamic type languages such as JavaScript, Python, PHP are becoming very popular for good reasons. So what Java community wants to do is they do not want to dictate developers to use only Java. They want developers to be able to use whatever language of their choice for a particular application, for a particular reason, for a particular environment. So at the same time, they want to have a tight integration and well-integrated environment so that they can take advantage of the strengths of both Java and other scripting languages. That is the motivation. So provide developers an opportunity to leverage advantages of different languages in the same application. And another side benefit is one of the advantages of using Java is because of the fact that Java has a lot of libraries out there. So you can actually extend your scripting languages by using existing Java technology libraries. So basically these Java libraries could be used in other scripting languages. So if you're writing JavaScript program, you can certainly leverage Java libraries inside of JavaScript. And that's really nice. And vice versa as well. So, if you're writing Java applications and if you take advantage of JavaScript libraries, and that's certainly possible from Java SE6. Another interesting benefit is produces an environment in which developers and end users collaborate to create a more useful and dynamic applications. One of the trends that has been, popping up during the past years was that people want to customize, meaning end users of your application want to be able to customize their application, and the best language for customization is in fact the dynamic type of languages such as JavaScript and PHP and Python. So it's rather difficult to customize your application using Java because that means you have to write code. By using scripting language for customization, you don't have to recompile your Java code. So that is actually in fact the quite good usage scenario of using scripting languages along with your Java applications. So by delivering Java applications that can be customized via scripts by end users. Okay, so scripting for Java platform was standardized by JSR 223. So it basically defined mechanisms for configuring JavaScript engine. No, not JavaScript engines, but Java scripting engines. In fact, the Java platform support all kinds of script engines. And PHP, Python, you name it. And it also provides APIs for mixing script fragments into Java applications. So you can actually use your JavaScript in your Java application and vice versa. Java platform comes with one single script engine, and that is actually JavaScript engine. And it is based on Mozilla Rhino engine. And there are in fact a lot of other scripting engines available. It's a matter of actually, plugging those scripting engines in your Java platform. For now, without doing anything, you can use JavaScript because it's built in Java SE environment. So this is the programming model. Very simple. You call script engine manager object, you basically create a script engine manager object. And from the script engine manager object, you specify what script you want to use. So if you're using JS, that means you're using JavaScript. You want to use a JavaScript, the engine. And then you are calling eval method of that engine, and then you provide a fragment of that the script code. Okay, so in this case, we are just displaying hello world. So we're going to do our first demo. So we are going to run a few sample scripting applications that are part of the hands-on lab, and then we are going to also run script path sample application that comes with JDK 6 as a sample application. So here we go. So you open those applications. So let's try the simplest possible application. So this is a main.java. So here we create the scripting manager object, and we indicate we want to use a JavaScript engine, and then this is a script, and then we are calling eval method. So let's run this application. So it's going to just display hello world. Now let's try to display all the script engines that are configured on Java SE platform that I have. In my case, as a it has only one. So if you take a look at this code, basically we are we get script engine manager object, and from the scripting engine manager object, we are calling get engine factories method, and then we are basically getting a list of script engine factory objects. So we can display the name of the engine, version of it, language support, and extensions and MIME types and names and things like that. Okay, so let's run this application. We should have just one because I have not configured anything else. Okay, so this is the result. So this is engine name is Mozilla Rhino, and engine version is 1.6, and language support is ECMAScript because the JavaScript has actually different languages. Language varieties. Again, language version is 1.6, extension is JS, and the MIME types are like this, and these are basically the names you can use. So you can use any of these names in your code. So if you take a look at the code, we use JS, right? But you can use, for example, JavaScript. So in our hello world application, instead of using JS, you can use JavaScript. Okay? Those are all possible names for referring to JavaScript engine. Now, typically, your JavaScript is going to be in a separate file, right? So, what you want to do is you want to run JavaScript file that is in a separate JavaScript file. So we have sample JavaScript.js file. So this is the simplest possible, let's say, JavaScript code. It creates a function, and then we call the function, and then we display the result. So in our main code, we are reading that JavaScript file, and then we are calling just eval. Okay, so this is the case that you are reading the JavaScript file in the class path. If you want to read your JavaScript file from the project location, then you can use the file reader like this. Okay. All right, so let's see, and let's see the code. Let's run the application. So let's run this application. It should just return 15 because in our JavaScript code, we define a function and then we call add and provide, 10 and 5. So it should return 15. So that is the result. Okay, pretty simple. Now let's take a look at more complex application. So script path is a bit more sophisticated application that comes with JDK 6. So let's run the application. Okay, so you can simple, and this is the code. This is the examples JavaScript code that comes with this application. Then you can just run it, and it will just display alert and examples. And let me actually show you one thing: Java Object Access. So take a look at this code. You can use Java code inside your JavaScript. So you see you are creating JFrame object, and then you are saving it into JavaScript variable called fr. And then you can call the method of the Java object. So this is an example that actually shows how well integrated between JavaScript and Java. So you can actually use Java object inside your JavaScript code, and vice versa as well. Okay. Mohammed, is there a toll-free number for dial-in? Unfortunately, no. So you have to use your computer's microphone and not microphone, but your speaker. Okay. Okay, moving forward, let me just close this application. Web services. I'm not going to spend time actually explaining all this web services concept. We have, in fact, web services course in JPassion.com. So in Java SE6, these web services supports are built in. Okay, so you don't have to run your web services over some kind of servlet container. Because Java SE6 comes with a very small HTTP server, so it is in a sense a lightweight HTTP server that could be used to deploy your web services. So it is JAX Web Services standard based, and it's using JAX P2.0, and it also has JAX P and stacks. And all the web services standards such as SOAP 1.2 and of course 1.1, and WSI Basic Profile 1.1, and XOP and MTOM, and it also supports REST, and it's also of course totally on XML schema based. Right? So your complete web service support is now available on standalone Java SE. So that's the point. Okay, so the way that you are going to build and deploy your Java SE standalone web services is basically creating endpoint object and then publish. Okay, client code doesn't make any difference, because client code could be the standalone client, or it could be web application, things like that. But in Java C, basically you can build and deploy your web service endpoint as a standalone web services. Okay, so this is how we are going to build web services endpoint over Java C. So first of all, you are going to create a POJO class, and then you are going to use @WebService annotation, and optionally you can inject web services context. This is optional, so this is used when you need to actually access some context information. And then you are going to use publish method of endpoint class. Okay, and that's it. And then WSDL gets automatically generated during runtime. And from the client, you can in fact see the WSDL, the document by adding question mark on WSDL. Okay, so the publish method is the one that you're going to use to start publishing. And if you want to stop publishing, then you can just call stop method of endpoint. And once it's published, then client can access the web service. Okay, and so basically this is the WSDL, and then client can actually use this WSDL to create a client proxy object to access your web service. Okay, so this is an example. So here we have a POJO class called the calculator, and all you have to do is basically using @WebService annotation. When you're using @WebService annotation at the class level, all the methods in your class will be exposed as web services operation. Okay, and here we are also using web service context. Well, inside the code we are not using it, but you can actually have an access to web service context, and it's dependency injected by the so this is dependency injected, and then all you have to do is calling publish method of endpoint class, providing URL. Okay, and then you also have to pass your web services the object. Okay, calculator. Okay, so client-side code is not that much different from web service client code that you are going to see any place. So basically, well, at least for the from standalone environment, you basically have an access to the WSDL document, then you're going to generate some proxy classes, and then you are going to call new method on the service class, and then you get a proxy object by calling get name of the service and port method. Then you can invoke remote methods of your web service endpoint. Okay, so this is a client-side code. So you call the calculator service object, and from the calculator service object you are going to call get calculator port method, and then you get the proxy object, which is a type of calculator. This is the interface, right? And then you can call the methods defined this in this interface. Okay, so the sample application that we are going to run is eBay web service and client application that come with the JDK 6. So let's run that application. So I have already opened those sample applications that come with JDK. So this is eBay server code. So let's take a look at the code. So the main is basically, so we're actually publishing two endpoints. So the one that we are going to use is this. Okay, so we have eBay, the object, which is a web service endpoint, and then this is the URL the client will actually use to access this web service endpoint. So let's take a look at the eBay. So eBay is basically the POSIX class with web service annotation. Okay, so I believe, let me see whether I'm actually already running it. I believe, yeah, so I'm already running it. So when you run the application, it is ready to receive web services request from the client on this particular URL. So let's actually try to see whether WSDL document is available. So I'm going to just copy it, and if the web service is up and running, I should be able to see WSDL document. It is still transferring. Okay, here you go. This is the WSDL document of the web service. Okay. Alright, so let's run the client. So I'm going to run the client and run. And it's the standalone Java SE GUI application. So here I have to actually specify the item ID like this. And you can go to actually eBay server on the net, or here I'm going to use a local server, and then in that case it's going to access the web service endpoint that we published on the local server and get details. So it is basically getting the information and display. Internally it's actually using another web service endpoint, the image provider web service endpoint. And if you, yeah, so pretty straightforward. Okay, moving forward. Database. So JDBC 4.0 support has been added. So basically added APIs, enhanced APIs. Exception handling improvement. Before JDBC 4.0, it has a single exception class called the SQL exception. And that's not really fine-grained. In fact, in order to find out what really happened, you have to actually, poke around this object to get more state. Now with JDBC 4.0, there are more concrete subclass exception classes. Subclasses of this SQL exception, which are more fine-grained subclasses. The blob and CLOB functionality, you can now call set club and create club method and things like that. And SQL XML data type, this is probably biggie. So, a lot of database now support XML as the first class data type. Okay, so JDBC 4.0 now has SQL XML data type, and you can certainly use this data type in JDBC now. Okay, moving forward, desktop APIs. So desktop APIs have a few improvements: tray icon, and splash screen, desktop class, and dialog modality enhancements, and text printing, and also swing improvement, group layout, and JTable sorting and filtering, and swing worker. So let's actually talk about each of this in a bit more detail. Tray icon. So you can access the system tray in your Java application. So these are the classes that you can use: system tray and tray icon. So system tray represent system tray of your system, and tray icon is just icon that will be displayed on your system. And it gives you the ability to add graphics, pop-up menus, and floating tip functionality to the system tray. Okay, so this is very convenient for your Java application. So here, you can add this tray icon, and if you click it, you can actually have menus like this and things like that. So this is the code. You are going to create an icon first by using tray icon class. You provide the image, and you can also provide a pop-up menu object. And then you are going to add event listener to this tray icon, so that when tray icon is clicked, this event listener will be used to do something. And then you are going to add this tray icon to the system array. So you're going to use a system tray class, okay, and call get system tray, and then you are adding this tray icon. I'm going to give you a demonstration in a few minutes. Why don't I actually do that? So I'm going to actually do demonstration one by one instead of altogether later on. So the tray example. Okay, so here, this is the tray example. So here we system array, and the image that we are going to use a Duke JPG file. So Duke JPG file is if you take a look at the file view of this one, then you are going to see Duke image is right here. Okay. Okay. So you're looking at the code, and we also have a mouse listener, and this mouse listener will be to the icon. So basically okay, so this is the action listener when exit is chosen from the pop-up menu. So we can have a pop-up menu, and then when pop-up menu is clicked, we are going to execute this action listener. So there is actually event listener for pop-up menu and event listener for clicking the icon. So create pop-up menu, and now we are creating tray icon with the image, Duke image. And then this is action listener. So that is, so we set the set image autofocus and action listener and mouse listener. So, all right, and then we are adding that icon to the system tray. So let's run this application. So, you are going to actually see the Duke image on the system tray. So you see the Duke image here. So when I click this one, you can see there is the event, mouse pressed and release clicked, event listener. Okay. So this is the right click it, then you can see the menu, then you can exit out. Okay. So that system tray is now exit out. Okay, moving forward, splash screen. So before Java SE6, Java runtime needs to be fully loaded and initialized before visual image can be displayed, meaning your complete application has to be loaded before you can display anything on the screen. And this could be a problem for reasonably good sized applications. Suppose your application is pretty large application and takes about a minute to get loaded. In that case, user is completely frustrated, probably not seeing anything on the screen, right? So in Java SE6, before your application gets completely loaded, you can display a splash screen for indicating something that is going on. Okay, so you can display a splash screen for application instantly before Java runtime software starts, meaning before your application is completely loaded and started. So the image that you can display could be GIF file, PNG file, and JPEG file, and the transparency and translucency and animation, you can have all those things in your the images. And as soon as your application is up and running, meaning your first top level window gets displayed, this splash screen will go away automatically. Right? Alright, so in order to use a splash screen, basically you are going to run your application using splash option. So you say Java -splash, and then you provide your image, okay, and then your application. And or you could have this one, if you're running your application from a jar, then you can have this one inside the manifest.mf file like this, okay. Okay, so the painting. So you get the splash screen, and then you get the create graphics and splash update. So you can actually choose the image shown after splash screen is loaded, but before application gets started. So you have some programming control as well. Alright, so let's run the application. So in this case, splash screen, splash test 2. So let's run the application. The image that we are displaying is this. This is a Brazilian national flag, so it's being displayed while application is being loaded. Okay, and as soon as application is ready, like this, and that splash screen goes away. Okay. Alright, so hopefully that gives you a reasonably good idea how it works. Moving forward. Desktop class. So new desktop class called the java.awt desktop class has been introduced. It has the enumeration of actions that may be supported for file or URI. Well, the thing is this, typical desktop environment has a default browser and default editor and default mail application and default print and things like that. So what you want to do in your Java application is, you want to display your default, system default browser or system default editor and system default mail application, right? So that's basically what you can do with desktop class. To find out whether this feature is supported or not is, you can just call is desktop supported method, and it will return true or false. And if it returns true, then you can call, for example, desktop, mail or something like that, and it will start the mail application. So let's run the application. So this is the desktop application. So let's run the application. Okay, so this is the Swing application. Now I want to be able to launch my system browser, so I'm going to provide URL JPassion.com. like this, and launch browser. So my system browser is Chrome, so it just displays the website, and mail recipient. So I'm going to actually run the mail application of my system. So again, click the launch mail, and it should return. Oh, looks like my Thunderbird is actually dead. So it happens once in a while when my Thunderbird is not in a good mood. Okay, so at least it's trying to run the Thunderbird application. Alright, so if you take a look at the code, basically it's using desktop class. So this is the desktop class. Sorry, this is the desktop class. Okay, and then desktop action. So if you take a look at the Java documentation of desktop, it's basically you can call the mail method, then it will launch a mail composing window. If you call browse method of desktop class, providing URI, it will launch default browser. Okay, and if you call open method with a file, then it will launch the associated application to open the file. On my Windows system, it will actually have a file open kind of application being popped up. Okay, moving forward. Modal dialogues enhancement. So what is the definition of modal dialogues? Modal dialogues block all input to some top level windows. That's modal dialogues. Okay? So in pre-Java SE6, the modality of your dialog could be either true or false. So when you create a dialog like this, the only option you have is modality of true or false. That means when you are setting this one to true, then until your dialog is closed, you cannot do anything. Any, let's say, other top-level windows cannot be accessed. Okay. In Java, that's a little bit too crude. So in Java SC6, more fine-grained modality is possible through modality type enum type. Okay, so modality enum types are like this. So it could be modeless. This is the same thing as setting this one as false. That means you're not creating a modal dialogues. Instead, you are creating modeless dialog. Okay, so this is modeless, does not block any other window, meaning even if your dialog is up, you can go to other top level window. Now, these are more fine-grained modality type. So when you set it to document model, then it will block input to all top level windows. Sorry about that. All top level windows from the same document. If it is set as application model, then it will block all windows from the same application. If you set it to toolkit model, then it blocks all windows that run in the same toolkit. By the way, when we say toolkit, we're talking about same AWT package. So it is a bit more fine-grained, and we'll see how this one works, using the demo. So if you don't understand what I'm talking about, that's perfectly fine. It also introduces what is called the modal exclusion type. So suppose if you want to have a dialog, and that dialog does not, then you want the dialog to be modal excluded, meaning you don't want that dialog to be affected by modality of others. Okay, so let me repeat that. So let me actually use this statement. Any top level window can be marked not to be blocked by modal dialog. So this is what I meant. Okay, so this is called the modal exclusion, and this modal exclusion could be specified by modal exclusion type enum. Okay, so let's say those enum. So no exclude, that means you're not really excluding your dialog in this. So this is actually pretty much the same as before. Now application exclude, when you use the application exclude for your dialog, that means the top level window would not be blocked by any application model dialog. Okay, so if you set your dialog to be dialog from the same application, any other top level window or dialog cannot block this particular dialog that's typed with the application exclude. Toolkit exclude is the top level window won't be blocked by application model or toolkit model dialogs. Alright, so let's run the sample code. So sample code that we are going to use is from this in our hands-on lab, modality demo 2. Okay. Alright, so let's run that. Okay, so this one actually needs some, the explanation in terms of what it is all about. Modality demo 2 project. Okay. So I have to have this one moved a little bit. So I have these 4 different frames. Okay. So this one we are going to create modeless dialog. So when you have a modeless dialog, it should not block anything else. So I can go to other window like this. Okay. Other window, that's perfectly fine. Okay. Alright, now I'm going to create a document model. So click this one. Now it's going to create document model dialog. What this means is that when you select this one, you cannot go to. Actually, let me try this one. So this is the same thing. Create modeless, same thing as this one, and then we got the document. Okay. Now, this guy is actually coming from this document, and this guy is coming from this document. So when you're actually creating a dialog with document modality, that means the things from the same so in this case, for this particular dialog with the document model, you cannot go to any other top level window that is coming from the same document. However, because the document model, I can go to different document. This is actually from a different document, right? This one, this one. But again, this is the same thing. This is the document model dialog. So I cannot go to these two because they are in fact from the same document. But I can go this. Okay. All right. So that's document modality. Now this is now let me show this one, excluded frame. So this is the dialog that is using this one. It's actually using application exclude modal exclusion type. That means this one is excluded from the blocking. So when I select this one, basically I can go any other place. Okay. Now this one, show the dialog. This is the case. So this is a case. It is actually creating file dialog, and this file dialog is created using old dialog method, dialog object, where it is set with true, meaning it is it is blocking everything. So once you have this one, you cannot go any place else except this guy. Okay, because this is excluded. Okay. From the same application. These are all from the same application. So except this dialog, you cannot go any other place. Okay. So let's actually see the code. So this is a code. Let me show this code first. If you see this code, so this is the first document, red document. This is the blue document and green document. So I want to actually show you file dialog. Yeah, here you go. So if you take a look at this file dialog, okay, and if you take a look at the source code, you get the source code. And it's using the dialog. So this file dialog is the extension of dialog. Okay, so parent class is dialog. So inside here, when you create the parent dialog, it's calling dialog parent, and then it's setting to true. Okay, so that means modality is set to true, meaning it is modal dialog. It's blocking everything else. Okay, so that's the reason is blocking everything else except except excluded, because what we have done is for document 3 we use this modal exclusion type called the application exclude. So if you take a look at the documentation of this one, basically application exclude indicates that top level window won't be blocked by any application modal dialogs. Okay, so as long as they are from the same application, this particular dialog that gets started with this exclusion will not be blocked. Okay? Alright, so hopefully that gives you a sense of, how things work. Alright, let me move on because we have a lot more slides to go. So we just talked about this. Text printing, so easier print to swing text component. And swing worker. So swing worker has been around for quite a while. Now it's part of Java SE SDK. Okay. So basically make it easy to offload work for two separate threads. So if you're writing your swing application and if you are trying to deal with user event using dispatch method, a dispatch thread, then your UI is going to be completely blocked. So what you have to do is you have to create a new thread yourself to handle that user event, right? So by using swing worker actually provide all that functionality for you, right? So it is actually has been around for quite a while now. It's part of the JDK Java platform, so you can take advantage of for building multi-threaded application with swing. Group layout class. So it is new layout manager to support new Matisse GUI builder. So the application that actually, the leverages group layout class is in fact NetBeans IDE, where you can actually build your GUI application using group layout manager, and it makes life a lot easier. So since we actually covered this one in one of the topics of Java SE programming course, I'm going to just move ahead. So horizontal, vertical, both horizontal and vertical. So instead of actually you manage the layout yourself in your program, now you can leverage group layout class. That does a lot of work for you. Okay. JTable sorting and filtering. So things could be, now the table could be sorted. Okay. All right. So I'm gonna just skip this one, and all right. So let me just run the table sorting application, because that's simple. Table sorting application. So here I can just sort. Okay. All right. It's just a new API for handling the sorting. That's nice. Okay, monitoring and management. So potential problems that can be detected, of course, the problems that you have on your JVM could be memory leaks, thread deadlocks, dirty references, infinite loops, and things like that. So JDK itself comes with a set of command line tools that you can perform some kind of monitoring. For example, JPS, it lists all the JVMs. JConsole is actually starting, JConsole has been shipped from JDK 1.5, so this is not new in JDK 6. But JPS, JMap, JHAT, JStack, these are command line tools that you can use to find out what's going on your platform. Alright, so you can actually use this hands-on lab called the Java Performance JDK tools. So let me just show you a few things. So let me call JPS. So it displays all the JVM that are being, being run on my platform. JPS -L, it give you more detailed, just a little bit more detailed information. And let me actually take a look at the documentation of that hands-on lab, and labs and the performance JDK tools documentation. So the one used here. Okay, so basically here we're just running, some application, we don't need to do that. So, okay, and so you can call the JPS help, JPS -L, -lv, a lot more variables. And you can use the JConsole. So the JConsole is a very powerful application. So if you run the JConsole, again, this is actually started from the 1.5, so really nothing new in JDK 6. So you can see all the local processes, right? And you can select one of, let's say, eBay server, my web service. You can connect. Then you can find information about this guy's memory usage, and the thread is using, classes is using, the VM summary, and mbeans. So if these mbeans are in fact from the JVM, so you can find all kinds of management information of this particular application. So JConsole is pretty powerful tool. And let's see, and JMap. JMap is, for example, you can actually capture the heat dump by using JMap. So it's basically, once you got the heat dump, then you can use again, the JHAT or NetBeans or other ID. They actually have typical IDs like Eclipse and NetBeans is able to read heap dump, and then you can analyze the heap to see what happened. Okay, so by using JMap, you can just create a heap dump. So in this case, I'm actually creating binary format, and then file is this. Okay, so you can just use this binary dump later on, but you can use, for example, this is JMap of history information. JHAB, you can use the JHAB to read a file, and then you can actually perform, some information. Okay, so when you run the JHAB, it will actually display this browser, and then you can actually perform some query operation like this. In fact, there is an object query language, so you can find out, what is the number of references of a particular object and things like that. So this is actually useful when you're trying to debug some very core, deep down Java problems. Okay, and you can actually read that heap dump inside the NetBeans, and NetBeans will actually pretty much do the same thing. Okay, so moving forward. Compiler access. So, basically in JDK 6, it opens up programmatic access to Java C. So you have an access to Java C. So that, if you're building, for example, the app server, servlet container, whenever JSP page is loaded, you have to compile it, right? So in that case, you could actually leverage this compiler access way of optimizing the compilation of certain things. Okay, so basically this is for the framework and tool vendors. Okay, so it's not for end users and developers, I would say. Pluggable annotation. So in JSR 1.5, JSR 175 of JDK 5 introduces the concept of annotation first time. In JDK 6 through the JSR 269, you can actually have a pluggable annotation processor. So you can build your annotation processor, and then then you can use it when you are processing annotation. So annotation processors act as plugins to the compiler, hence pluggable annotation processing. So you can certainly customize, annotation processing. So example is, for example, let's say we have annotation called for review, and then you're going to create the annotation processor called for review processor. And then when you run the code, when you're compiling this Java code.java, you can actually provide this annotation processor using processor, the option. And basically this is the one that will, the process, whatever annotation that is capable of processing. Okay. All right. So this is that is in fact sample application that comes with JDK 6. Okay, and of course JDK 7. So I'm going to actually use documentation. So I documented as exercise 8. So, when you go to this code, you can go to this code. In my case, I have this code is in fact the process. This is the annotation processor code. Okay, so I'm going to compile it, and I'm going to compile it, and the actual class file will be inside the process dir. So I have already done that, but let me try it again. Sorry. Okay, looks like you are not seeing it right. So let me just do this. It's rather difficult to work in a small screen space. Okay, so I created procedure. Okay, so it created the processor class file, and then I am going to so the same processor code has actually some badly, this class defined. So we are basically, handling this code by using this annotation. So, let me just run this guy, and then I'm going to show the code. So annotation processor will actually deal with, this class indicating some warnings. Okay, and this is actually from the processor. Okay. So if you take a look at this code, Yeah, so it is actually extending abstract processor, and at the end of the code, it's basically processing this badly named code. Okay, all right. Okay, desktop deployment. So in JDK 6, the performance improvement on desktop, graphics hardware acceleration on Windows, and perceived performance is also improved, and improved native look and feel, and also Java Web Start and JLE installation. So if you run the sample application of swing set, again, this comes with JDK 6. So let's see, swing set 2, if I run this application. Okay, so basically, you can choose the look and feel. This is Java look and feel, this is Motif look and feel, and this is Windows style look and feel. Okay. So that is the improvement. And security, new APIs are added. So XML digital signature API and smart card IO API is added, and also improved authentication schemes. So Java authentication and authorization security, the scheme, the based authentication using LDAP, and the GSS APIs are also supported. Quality and stability and compatibility, again, a very important aspect of it. Alright, so performance improvement. So you can see the performance improvement. This Tiger is 1.5, and Mustang used to be the code name. So you can see some performance improvement in Swing. And this is the server-side performance improvement. So server-side performance improvement is a bit more dramatic than client-side. So Java C, so application run faster on desktop as well as on servers. Dynamic attached diagnostics simplify troubleshooting. I didn't mention this one yet, but this is actually pretty powerful. So in Java C5, in order to have your application to be remotely diagnosed, you have to restart your application using an option. I forgot this, -debug something. In Java C6, you don't have to restart the application. And this is nice because in production environment, if you're running your application in production environment on Java C6, you can directly connect without restarting that application. So it makes your life a lot easier in terms of finding out what's going on your production server, assuming it's running on Java C6. Again, we talked about improved look and feel, and first Java platform with the full support of Windows Vista and Windows 7. Okay, so that's the end of the presentation. So let me actually go over the hands-on lab briefly, and then we are going to. So basically, exercise 0 shows how to open sample and demo apps that come with the JDK 6. Exercise 1 is a scripting. Exercise 2 is web services, and basically, I demoed all these things as part of the presentation. So, this is in fact documented. So you can just kind of try these things yourself after downloading the zip file. Okay. All right. So let me just finish that.